My name is Kristóf Nyári. I'm currently a senior DevOps engineer, and today I'm going to be talking about multi-tenancy, which I may be a bit late with. So, first things first, what is multi-tenancy? At a high level, multi-tenant solutions are all about sharing. Thus, multi-tenancy in Kubernetes is the practice of running multiple workloads in isolation from one another. Okay, cool. While sharing the same underlying resources, or don't, as we'll see in the next few minutes. This in turn allows multiple tenants, such as teams, customers, or applications, to coexist on the same infrastructure. But naturally, every great thing comes at a cost. By default, Kubernetes does not enforce API or isolation, or network or resource isolation actually. Any workload in Kubernetes can freely talk to any other pod, and the scheduler may place one pod next to another from different customers. This is not what we like. So some challenges always arise with this vision. Let's start with resource allocation and contention. In a multi-tenant environment, it's really important to make sure each tenant gets the resources that they need, without stepping on each other's toes, that's it. Kubernetes offers some native tools to help us, such as resource quotas, limit ranges, or HPAs. Also, another key thing is security and access control. Preventing unauthorized access between tenants is absolutely critical. Fortunately, there's also a solution in Kubernetes called Airbag and network policies, which I'm sure many of you are familiar with. Also, then there's the issue of scalability, because as you scale up, managing multiple tenants within the same cluster becomes increasingly complex. It's a balancing act, you know. On one hand, you want strong isolation. On the other, you want to keep operations manageable. Finally, then there's the version management, which also becomes a pain, because supporting different versions across clusters can actually become a headache. It's a challenge that requires careful planning to avoid issues in the future. I've also brought you a quick comparison between cluster and namespace based. There is sadly no time to really explain, but the key things I want to highlight are the isolation stuff, because one is physically isolated and the other is logically, meaning that with cluster-based multi-tenancy, they don't run on the same cluster, thus not sharing any resources. And also the resource efficiency, which is, just what I've talked about. So let me introduce you to Gardener, which is just a tool for this. The developers of Gardener took the phrase, every application can be run in Kubernetes, and took it a bit too seriously, because they thought, why not run Kubernetes in Kubernetes? Or at least that's what I thought. Well, I can ask the SAP guys. So, just a quick overview. In Gardener, you can create two types of clusters called seeds and shoots. The seed clusters are managed by the central garden cluster, which also houses the main etcd. These are managed by an agent called Gardenlet, kind of like how the kubelet works in a normal setup. These seed clusters run the control planes and their components as native Kubernetes workloads, such as deployments and stateful sets, taking advantage of every known benefit of those things. The other, there are shoot clusters, which actually do the work, as in they are the user-facing clusters. To put it simply, think of shoot clusters like pods and seed clusters as the worker nodes that run those. But how does this relate to multi-tenancy, you ask? Well, the operational complexity is vastly reduced with this, thus the cluster-based multi-tenancy becomes a bit more attractive. So let me present our solution. The problem statement was clear. We had two customers with very identical needs in regards of infrastructure and applications, but they couldn't see each other. We also had to manage a way to oversee these clusters. So this is a very oversimplified version, by the way. But we provisioned 5 clusters in total, with the central cluster only being accessible by us, and 2 for serving end users. The stateful and stateless workloads are also separated, thus the separation within isolation zones, such as the yellow and the red one. Otherwise, the infrastructures were identical. So, without getting too much into it, this achieves the goal of physically separating the two customers while making provisioning and managing the infrastructure a breeze. So yeah, to conclude this talk, you should be able to evaluate whether multi-tenancy is a good solution for you, or if it's required. If it is, then you can suggest solutions, tools, or architectural patterns to help your company with And also, if you want, you can catch me at the after party. Thank you. Have a great rest of the night.